Welcome to your Finite Math Lesson 5.1 on simple and compound interest. Simple interest. We're going to start with simple and then we'll move to compound. Simple interest is used sometimes. Interest on loans made for a year or less sometimes is calculated as simple interest. It's simply the amount of interest paid or charged only on the amount borrowed, not on or the amount loaned or invested. It's not on past interest. So you don't pay interest on your interest. So some important terms for you to know is whenever people are talking about investments, the principal is the amount of money either borrowed, loaned, or invested. It's the initial amount. The rate that people refer to is the annual percentage rate, APR, and it's the percent charged or paid per year on the principal. Now, since this is in terms of years, the time has to be expressed in terms of years. And when they talk about the time of the loan, that's the length of the loan or investment. Okay, so our formula for simple interest is I equals PRT, where I is the interest, P is the principal, the initial amount, R is the annual rate of interest in decimal form. So if they tell you the APR is 5%, then when you plug it into the formula, you're going to plug in 0.05. T represents time measured in years. So if they tell you 4 years, T is 4. If they tell you that it's 4 months, then T is 4 out of 12, 4/12ths of a year, so a third. To borrow furniture for a new apartment, Jennifer Wall borrowed $5,000 at 11% simple interest for 11 months. How much did she have to pay in interest? So to find the interest, we just do principal times rate times time. Now, I do want to point out you don't have to worry about memorizing the different formulas because you're going to get a bunch in this chapter. For any assessment, you'll be given the formulas. You just need to know that if it's a simple interest, this is the formula you need to use, and you need to know how to plug in the numbers. So our principal amount is $5,000. The rate is 11%, so in decimal form it's 0.11. And then the time is given to us in terms of months, so we divide that by 12. So 11/12ths will give us the fraction of a year that we're talking about. So it's 11/12ths of a year. And you just grab your calculator and multiply that out, and you get $504.17 is the amount of interest that she'll have to pay. Now, that's not the total amount she'll have to pay because she's got to pay back that initial $5,000. So how much money was due at the end of the 11-month loan, not 11-month-old, $5,000 because she borrowed that much, and then the interest. So you're going to add those two together. It's going to be principal plus interest. And so you get $5,000 plus $504.17, and you get $5,504.17. The total amount that Jennifer will have to pay at the end of the 11 months is called the future value, or I like to think of it as future amount because we use a capital A to represent it, or maturity value or maturity amount. So A is going to equal P plus P times R times T. PRT is interest, so it's just principal plus interest. You also could factor out the principal amount and do principal times 1 plus RT, where P is the principal, the initial amount invested, R is the annual rate of interest in decimal form, and T, as always, is time measured in years. Okay, compound interest is used much more frequently than simple interest. It's the amount of interest paid or charged for a loan or investment, not only on the amount borrowed, loaned, or invested, but on previous interest as well. So if you're talking about loaning, you pay interest on your interest. And if you're talking about investing, you get paid interest on your interest. All right, so whenever you read you've got compound interest, you're going to be looking at A equals P times 1 plus I to the nth power. A is still the maturity future amount or value of the loan. P is still the principal amount, the initial amount. R is still the annual percentage rate. T is still time measured in years. Now, ILM is new. It's the number of times interest is compounded per year. We don't have to worry about that with simple interest because there's no compounding. But now we do. Now, here's some examples. Semi-annually means 2 times each year, so M is equal to 2. Annually means once per year, so M is 1. Quarterly means 4 times per year, once a quarter, so M is 4, and monthly means once each month, so M equals 12. You need to know these because you need to know this vocabulary. You need to know if someone says it's a semi-annual sale, that means it happens twice a year. Okay, you just need to know these vocabulary terms. So N is going to be the total number of times the interest is compounded over the life of the loan or investment. And so what you're going to do is you're going to take the number of times per year the interest is compounded and multiply by the number of years. So N is equal to M times T. I is the interest rate per period, per payment period. So it's going to equal the annual interest rate divided by the number of times per year that the interest is compounded. So I is going to equal R over M. All right, so we're going to find the compound amount for each deposit and the amount of interest earned. So we're going to find the future value first, the compound amount, the future amount, and then we're going to find the amount of interest that was actually earned. So here we've got an investment situation. Part A has $1,000 at 6% compounded annually for 8 years. So we have an initial investment of $1,000, so that's our value for P. R is equal to 0.06 because it's 6% there, compounded annually. That means M equals 1. So when we use I equals R divided by M, we're going to do our 0.06 divided by 1 is just 0.06. N is going to equal M times T, so 1 time per year times 8 years gives us 8 times that the interest will be compounded. So let's plug these values into our formula and we'll be able to calculate A. So A is equal to 1,000 times 1 plus 0.06 to the 8th power. Well, 1 plus 0.06 is 1.06 to the 8th power times 1,000 is $1,593.85. So now that's how much is in this account. Okay, this account where $1,000 was deposited. So now we want to know, well, how much interest was earned? Well, it's going to be the amount that's there now minus the initial amount. That will give you the interest. So $1,593.85 minus $1,000 is $593.85. That's how much interest has been earned. All right, same type of problem. The only thing that's changed are the numbers. So our initial amount of principal is $8,500. Okay. I is equal to R over M. So let's see, our annual interest rate is 8%, so 0.08. We are compounding quarterly. So the quarterly here tells us that M is 4. 0.08 divided by 4 is 0.02. N is the number of times the interest is compounded, and so it's going to equal M, the number of times per year, so 4. Times T, the number of years, so times 5, and so we get 20. And again, like I said, P is 8,500. So to find our future value, our future amount, we plug in these values. So 8,500 times 1 plus 0.02 to the 20th power. So 1.02 to the 20th power times 8,500 is $12,630.60. So that's the compound amount. Okay, that's the future value right there. The amount of interest that we earned is this future value minus the initial value. So $12,630.60 minus $8,500 is equal to $4,130.55 earned from interest. Okay, so for example 3, we're going to kind of look at things backwards, find the present value, the amount that should be invested now to accumulate the following values. So present value, that's just another word for principal. So it's good that they both start with a P because we're looking for P. We want to get $2,000 at 6% compounded semi-annually, so that means M is 2 for 8 years. So I want to end up with $2,000. I'm looking for how much I need to invest right now, what my principal should be. So I is equal to R over M, so 0.06 divided by 2, so 0.03, because remember semi-annually means twice a year, so M is 2. N is equal to M times T, so 2 times 8 is 16. So let's plug in these values. So we get 2,000 equals P times 1 plus 0.03 or 1.03 to the 16th power. Now I want to solve for P, and it's being multiplied by this expression right here. Don't evaluate 1.03 to the 16th power because you're going to be tempted to round it to too few decimal places. We're just going to divide both sides by that amount. So I'm going to get 2,000 divided by 1.03 to the 16th power equals P. And thanks to our nifty calculators, it's really easy to put that in there. And so we get P equals $1,246.33. So if I want $2,000 in 8 years and I can get 6% compounded semi-annually, I need to invest $1,246.33 into that account and just let it sit there. All right, one more formula to work with today, effective rate. The effective rate corresponding to a stated rate of interest R compounded M times per year is R with a little e at the bottom. That's how you know it's the effective rate. Okay, see the little e? That's telling you it's the effective rate. Equals 1 plus R over M. That's our I value from before. To the nth power minus 1. So, a bank pays interest of 4.9% compounded monthly, so M is 12. So we want to find the effective rate. So we're going to plug in the appropriate value. So 1 plus 4.9% in decimal form is 0.049 over 12 to the 12th power minus 1. And so we get 0.050116, so about 0.050. So about 5%. So the effective rate is a little higher. Instead of 4.9%, the effective rate over the year is 5%. Okay, guys, go ahead and try the problems to try on your own. Make sure you've got your notes here with you because you're going to want access to those formulas and the definitions of all the different bits and pieces. But make sure you try them and come to class ready to work. Okay, I'll see you soon. Thank you again for taking such good notes. Have a good day.